So here in this problem, given that alpha and beta are the solutions of the trigonometric equation a times tangent of theta plus b times secant of theta equals c. Then using these facts, we need to show that the tangent of alpha plus beta has a value 2ac over a squared minus c squared. So let us begin. So let's talk about the solutions first. So here we have to find out, actually we have to prove it, but we'll start from the left hand side. So we have tangent of alpha plus beta. Now we know that tangent of alpha plus beta, that's given by tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha times tangent of beta. So meaning our task will be to obtain the value of tangent of alpha and tangent of beta individually using this particular equation. And once we have that, we can plug in those values into the left hand side, and this is going to help us prove that its value is indeed equals to 2ac over a squared minus c squared. So let us begin. So we'll begin with a given equation. So here in a given equation, we have a times tangent of theta plus b times secant of theta. So that's equals to c. Fine. Now what we'll do, I'll remove this secant theta. We'll have to get rid of it. So we will take a times tangent of theta. We'll keep it as it is. But we're going to transpose c from the right hand side to the left hand side, and we'll transpose b secant theta to the right hand side. So we have negative b secant theta. Now we're going to square both sides. So we have a times tangent of theta minus c whole squared. So that will be equals to negative b times secant of theta whole squared. So let's expand it. We're going to get a squared times tangent squared theta plus c squared minus 2 times ac times tangent of theta. So here what we have done, we have used the formula a minus b whole squared. Its expansion will be a squared plus b squared minus 2ab. And on the right hand side, we're going to have negative b squared will become simply positive b squared, and we have secant squared theta. Now we know for a fact that there is a relationship between tangent theta and secant theta. That means whenever we have 1 plus tangent squared theta, that's equals to secant squared theta. So we can replace the secant squared theta with 1 plus tangent squared theta. So we get a squared tangent squared theta plus c squared minus 2 times ac times tangent theta. So this will be equals to b squared, and to b squared we are going to replace secant squared theta, so we are multiplying 1 plus tangent squared theta. So further simplification gives us a squared times tangent squared theta plus c squared minus 2ac times tangent theta. So this will be equals to b squared plus b squared times tangent squared theta. So here we will transpose this b squared tangent squared theta to the left hand side and combine with a squared tangent squared theta. So we get a squared minus b squared multiplied to it is tangent squared theta. Then we have negative 2ac times tangent theta plus c squared, and we'll transpose this b squared to the left hand side as well. So we have c squared minus b squared, so that's equals to 0. Now we see here that this is a quadratic equation in tangent of theta. Quadratic equation, if it's a solution in x, we have ax squared plus bx plus c equals to 0. So our given equation is a quadratic equation, but it is in terms of tangent of theta. Now it's given here in the problem that alpha and beta, these are the solutions to the given trigonometric equation. So that means this particular equation, this is the same as this quadratic equation. They're exactly the same. We have only gotten rid of the secant function. So here it's given here that since alpha and beta are the solutions, this implies that tangent alpha and tangent theta are the solutions to the given trigonometric equation, are the solutions to the given equation. So now that we have the value of these solutions, now what's the sum of roots? We know that the sum of roots, that's simply given by the coefficient of tangent theta. It's negative times the coefficient of, let me write it down, it's the coefficient of tangent theta divided by the coefficient of tangent squared theta, which will be equals to, so that means the sum of root, that's tangent alpha plus tangent beta. So that's equals to negative of your coefficient of tangent theta, so that's negative 2ac, divided by coefficient of tangent square theta, so that's a squared minus b squared. So that means we have obtained tangent alpha plus tangent beta equivalent to 2ac over a squared minus b squared. So now we go to the product of roots. So the product of roots, so that's simply defined by as the ratio of the constant term to that of the coefficient of tangent square theta. So what's the constant term? So the constant term c is c squared minus b squared. We have c squared minus b squared, and the coefficient of tangent square theta is simply a squared minus b squared. Fine. So now we have the product of roots, tangent alpha times tangent beta. So this comes out to be c squared minus b squared divided by a squared minus b squared. Now we have tangent alpha plus tangent beta as well as tangent alpha times tangent beta. So we can come to tangent of alpha plus beta, which I've already defined at the beginning of the problem. So we have tangent of alpha, let's note it down. There's tangent of alpha plus tangent of beta whole divided by 1 minus tangent of alpha times tangent of beta. So we'll substitute these two values. So tangent of alpha plus tangent of beta into numerator, that gets replaced with 2ac over a squared minus b squared. And in the denominator, we have 1 minus the product, which is tangent of alpha times tangent of beta, that will be simply c squared minus b squared over a squared minus b squared. Fine. That will be equals to, now we have tangent of alpha plus beta, so that's equals to 2ac divided by, we have a squared minus b squared minus c squared plus b squared. So b squared cancels, so this is finally given us 2ac over a squared minus c squared. And this is exactly what we have been asked to show. So let's check it out. So we have 2ac over a squared minus c squared. Yeah, 2ac over a squared minus c squared. Hence proof.